demo. So before starting, I assume sample 3, you are inside the sample 3 compiled and the Karaf is running. So with the Karaf, you just verify all these things are installed, all the top fours are installed. You just do the list and grep sample app and check all this sample app feature which we wrote is installed. Okay, so before we run demo in the VM, we need to add the host only adapter. Okay, to connect to the controller. It will not connect. It doesn't have IP. It is working. I will show. So if we add host only adapter, it will get an IP. We can connect the controller. So I'll show how I have added. So in the preferences, for this particular, this is my mininet. This is my VM. Whatever VM you have, this is the same VM. And in this, I have this host. Okay, so this we can attach. Just we have to make some changes. It will have IP by its own. Just we have to enable the DHCP server. No, no, it's on the same VM. Just to have an IP to connect to the controller, we are running the DHCP server. It doesn't have an IP. Anything, no, none of the interface are in IP. Hmm. Not coming. Can anyone run? Does it has any IP if running? That IP is there. If you have some IP, then no need to do this. If the IP is there, then it is okay. Yeah. Okay. So if you have IP, then we can skip this step. Okay. So we have verified this. Okay, so we have verified our feature is installed. So now we'll check the communication. Now we connect the mininet to the controller. Okay. So first, before connecting, let's see netstat. This port is open. 6633 or 6653. You can check this netstat from any of your terminal in the VM. You just open the any terminal in the VM and do the netstat and check either 6633 or 6653. It should be listening, not established, because we have not connected the switch. No, you are running the Karaf 6633, 6653 or 55. Inside the VM only, just open another terminal and check the netstat. This 6633, 55 or 53. So this is the port through which the switch will connect to the controller. So this should be up and listening. So this port is in the listen state, right? No, it's there. Okay, so now we'll connect the mininet. So this is the same VM, whatever you all are having. Okay, so this is the command to connect to the mininet. Just run this command sudo mn hyphen hyphen controller remote IP. You give your IP, whatever it shows in the if config. So we connect the mininet to our controller. Sudo mn hyphen hyphen controller equal to remote comma IP equal to the IP which you have in your if config 10.0015 whatever. And then again do the netstat. It should be established. Yeah, it's already compiled. It's already compiled. Just run it. So this will connect two hosts, two switches to our controller. So we'll be up with the topology. Sorry, one switch, two hosts, and a controller. So controller is running wherever we are running the Kara. This will create a switch and the two hosts H1 and H2. So after this, it should be showing as established with our controller netstat. So this says that our controller is connected with our mininet. We created a topology. We created a topology with one switch, two hosts, and allowed it to connect to our controller. One switch is the open OVS switch. Two hosts are attached to the pseudo hosts are attached to the switch, that same switch. So this, when you run the mininet, it shows. Huh. So, see this. So when you run this command, it says creating network, adding controller. So controller is are this whatever you have connected to. Then it says adding host H1, H2, and switch S1. And the links are H1 is connected to S1, H2 is also connected to S1. So two hosts and a switch. This command itself has created a topology. Sorry? No, this creates a topology. You can see the link by a command. Set of flows. Huh. So with this command, okay, with this command, after your IP, you can specify hyphen hyphen topo, which is topology, and you can give linear or a tree or and then give the depth. So if you don't give anything, it by default creates a single switch with the two hosts. Huh. So this IP address is our controller IP. So if you do where in your VM, if you do if config, it will have a IP of IP to one of the interfaces. So there your controller is running. Your Karaf is running there. So you connect with your Karaf this mininet. Okay, so this has created a topology and connected to our controller. Our Karaf controller, yes. With the topology, because I haven't given any topology description here, so by default it's a linear topology with one switch and two hosts. If you want a tree with multiple switches and multiple hosts, we can specify a topology there. In this same command, hyphen hyphen topo tree comma 3 height depth 3 4 or whatever. So by default it's a linear topology. Yes, yes, and as well as it's yes. I'll show you if you want. Meanwhile, so if I exit this, okay, same command, I'm giving hyphen hyphen topo tree comma 3. So it has created so 7 hosts, so many links. Okay, so I have given a tree structure with three levels. If I don't give, it creates a linear with single. Yeah. So for our demo, I am creating only the single without any tree. Single switch, two host and a controller. Flows. Yes, to this switch. So now we will open our browser and try to push the flows. Okay. Yeah. No, not needed. If you have the IP, then not needed. If you run the if config, do you see IP to any of your interface there? Then it is okay. So before giving the flows, please check if your hosts are having IP. Okay. So okay. To check whether your hosts are having IP or not, run this command. You check if your host is having an IP. So from the mininet prompt, just run extern and the host name h1. Inventory is okay. So before we start pinging and going to the flow provisioning, let's see our hosts are having an IP. So host 1, if it is not there, I'll tell you how to give an IP. You can give sudo if config host 1, the IP 10.0.0.1. So this has IP h1 h0. How to go into the host? From the mininet xterm h1. Similarly h2 also we can check. So this is also, yeah, so this also should have IP, and please give this IP so that we can provision with this same IP the flows. So one host will be acting as a source IP, another host will be the destination IP. So if our your hosts are having IPs 10.0.0.1, 10.0.0.2. Hmm. That will be the private IP, and that will be used for provisioning the flows. One will be the source IP, and other will be the destination IP. While running the mininet, we gave that IP to connect to the controller. So whatever is the VM has an IP. That IP we gave. Okay, so if our host have IP 01 and 02, then we can. Okay, so then we'll start the actual fun. So we'll try provisioning the flows from our this good old RESTConf API. You sample app and go to the post and only give one by one. So you give only this thing. I'll put it in a notepad. You give only this part and source IP 10.0.0.1/32 to 32 and deny. So let's test for our deny use case. Which will go to the switch. So if we, it will be overwritten. Okay, so if we have pushed the, so put, but put is not working. Put is not working. Things are already having flows, so put will not work. Post only. Hmm. Does failed. Data already exists. So do you see flows on your switch? Run this command on another terminal and see if you have the flow. No, 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 no. Run this command. Check this command is there or not. Okay, okay. Huh. Do you see, anyone sees the flow with one as a output equal to 1, another two flows will be there, other will be drop. Which two? S1 is created with the mininet topology. When you create a mininet, it gives the switch name S1. Two flows, right? Two flows. One. No, two flows should come. R. Two for four, both. Yes. So one will be going there, but reply will come there and it will drop. So yeah, I'll also get back. Okay. Two, two. Uh, uh, I think we have to restart because there is no delete, right? Okay, 1 second, I'll show. Delete, it's not there. Delete, see, sample app delete is not there. Config data. Two flows, right? No, it will not be pinging. ARP is not there. We have to provision the static ARP. Okay. But how about delete? How you did? Sample app only. Inside sample app. Which REST API? That same doc. How you did delete? At this. Okay. Hmm. Hmm. Sorry. It can be resolved dynamically, but for that we need another set of flows. So it will go to the controller, punt to controller. Controller will send ARP reply, ARP request. So that is not shown in the demo. So we configure statically and just show the ping. Yes, but OVS doesn't do. OVS is a open flow switch that doesn't do that. That should take care. Yes, yes, yes. So this is a dummy open flow switch. OVS is a dummy open flow switch. Yes, yes, you are correct. L2 feature, it should automatically resolve. We can do here, but by the open flow. Open flow as in we have to have another set of flows which will send the request to the controller Controller will send ARP request, broadcast, it will get a reply, it will provision a flow. So that part is again a separate application. No, no. So L2 learning switch is not as same as our typical L2 forwarding. Okay, so it's just a open flow is a dumb thing. Whatever we provision the flow, it works. So that provisioning, there is no app such as it will do that. So we need to write that app. It's not there. Learning completely doesn't do that. It's not complete that way. That it resolves the R, provision the flows. That way, it's not complete. So similar to L2 learning switch, we have to write a complete app to make that dynamic ARP resolution. So for meanwhile, we are just doing the static thing and just demoing the ping thing. Huh. Okay, so I'm deleting it because data is already there, right? So we have to delete and then. No, no. The priority and the match is same, right? Priority, if we could have changed, then it would have been okay. Yeah, but it is hard coded in the code. So. Yes, yes. Manohar, delete doesn't. I do a delete, right? This thing, this thing, this thing only, right? So if I do, so if I do here, this thing, it's still there. So if I do a provision here, it doesn't show two things. So I'm doing a post again, okay? So you are doing permit. Why permit deny also it should have, right? No, two flows. Mm. So this is permit use case. Okay, deny will show after. Okay, so we will show the permit use case first and then override with the deny. So with the permit use case, we should have these two entries. So I'll explain why we have two entries. Okay. So with this also, ping will still not work. We need to configure the static ARP entries. I'll show that. So this is the permit use case. So we are saying, so host one and switch one. Host one and switch one are attached with the port out port one, and the host two is attached to switch with the port two. Okay, we can dump the port and see the hierarchy, the entire topology. What is the port 1 and 2? Okay, so what we are saying here, match on destination IP dot 2 and give it to output 2. Okay, and 1 and give it to output 1. Okay, so this is two way. Okay, so when we ping from H1, it will go to H2. And H2 will configure the static ARP entry so that whenever it comes from this H1, it knows the ARP entry for host H1. We'll configure that now. And then with the second rule, we'll get the ping back. So if we do this, we'll be able to do the ping. Okay. Now I'll show how to configure the static ARP entry on each of the hosts H1 and H2. So this is the this is the permit use case. It should have these two entries, okay, and this is the way we provision the static ARP entry. Okay, so for permit use case, what we'll do at host H1, we'll configure the ARP of H2 as in IP and the address resolution statically for H2, and similarly on H2 we'll do the for H1, so that when the ping comes, statically we are resolving it. This can be done dynamically, but for that we have to write a separate application which will take care of punting the mag learning and all. So it will be a separate application. So for now we are just doing statically. Okay. So if we configure the static ARP and do a ping, it will go through because we have both the rules. So I'll configure now the static ARP on both the hosts H1 and H2. For I'm doing it right now. Okay, so we'll start first H1, H2, both the host. Okay, so we have these two hosts, right? So the command is ARP minus S, the IP and the address. So at H2, it should be host 1's IP and address, and H1, it should be the opposite. So we'll do it right now. Okay, so this is, okay, this is my host 1, this is my host 2. So I am doing ARP minus S 10 0 0. This is 2, so I am configuring for 1, and for 1 the ARP the hardware address is this. So I'll do, so this has configured the static ARP. And similarly here ARP minus S 10 0 0 1, sorry 2, and this hardware. Okay, so now both are configured. Okay, so both has the static entry and we have our rules also. So now we'll run a TCP dump here to see the ping at both the things. Okay, and then we'll do H1 ping H2 from mininet console. Okay, so this is our mininet H1 ping H2. So the ping is successful. If you see here, ping is going here and reply is also going. Okay, so request reply goes from both the side, both the hosts are getting, and the ping is also successful with both the flows. Okay, so this is the permit use case. Sorry, TCP dump, just give TCP dump on both the hosts. So we will see the echo request going here, reaching here, reply from there. What you are giving? X term from the mininet console. X term H1. It should have opened somewhere. You have to check. You have opened, right? So no, don't give this hardware address. Just the IP and the address. No need to give that hardware. Just the address, MAC address. Other way also. Some block. No, there is one more way to go. Config H. Can you check? I can how to enter into the host, Mininet host. How to get into the console of Mininet host. Xterm is not working in this. Both you ping Mininet, you do H1 ping H2. TCP dump, if you want to see the echo request reply like this, you do on both the thing, do TCP dump. Here you do TCP dump, both the side. Mininet. H1 ping H2. Yes. You can see the TCP dump also. So echo request will go there, you will get the reply also. So this is the permit use case. So this is working for all. So then we'll move to deny use case. Okay, we'll move to deny. Okay, then we'll move to the deny use case. Wait, okay, okay. There should be some command to get into the console. Then ping from Mininet console H1 ping H2. R minus S, the IP of the other host, and MAC of the other host. Similarly for the second host. Other host. H1 will have IP.2 and the address of H2. H2 will have IP of 1 and address. How should I do it? Extern from Mininet. Where is your Mininet command? Mininet, everything from Mininet. From Mininet. This is your Mininet. Extern H1. So this is your H1 host. You do if config, you will get IP and address here. Similarly, you do H2. Then you enter the static R. Okay. R minus S. You open the H2 also first, so that you open the H2 also first. So you open the H2 also. So here you need H2's IP and MAC. So you need to 2 MAC. You need to go there and see. Open the extern H2. Then from here you put that IP and MAC. There you put this MAC and IP. Deny. Okay, we'll move to the deny use case. So I am stopping this. Okay, this already have the R entry. Only change we'll do is from the from this we'll just change permit to deny. Okay, and we'll provision the entry. Okay, so I am doing a provision here, and let's check what is there on the switch now. I'll do a delete and then do it. Yeah, I'm doing a get put, that's why it is not working. I'm doing a put, that's why it is not working. Okay, I'll do post. Permit to deny, yes. It's changed, right? Okay, I'll do a delete. Okay, so deleted. No, your flows are not going, that's why it will not stop. Okay, so for the drop, oh, okay, okay. So this is the deny use case, the second use case. Hmm. Deny, and you will get these two flows. Second, yeah. So this way it will go fine. The other way it will come back also, but since there is no output to the port 2, there is no second flow. It says drop, so it will be dropped. So ping will be not successful. I'll do a TCP dump. It will go one way. It will give a reply also, but it will not be given to the host one. First, by first flow, it will go to the host 2. Host 2 has a ARP entry. It will give a reply also. It will hit the second flow. Second flow says drop it. So H1 will not get back. It will not go. It will not go only. Okay. So my ARP entries are already there. Same entries. So I am not provisioning again. So I'll just do the ping, and here TCP dump. Okay. So both TCP dump I have run, and then from here I'll do H1 ping H2. Sorry. Okay. Okay. So this is not going through. You can see the TCP dump also. Why it is not going through? Okay. So this is sending a request, but it is not reaching there. Okay. So this is the deny use case here, and we just had a data path testing with a permit and a deny. So this is already two, so it should be one. But check the MAC also. MAC should be of one, not this. Not entirely. One flow will be. Yes. Only one flow will. Then one stale entry will be there because we have not coded for the delete. No, you have to provision the deny entry. Yeah, because it is not deleted. No, four. That will be hit. No, did you delete? from the access control list. Can you delete again? Yeah. Because yes. That you can do. Still coming. Some still problem. So you either you delete those two entries or manually or restart it. Restart the graph. Because this is only because in our sample app we have not coded for the delete part. We'll complete it. Similar to the create part, we have to code the delete part. That I don't understand. I have never seen this. Can you match your JSON with whatever I'm doing? Is it same? Does the priority change there? It can be used. Mininet. People use for demo. Yeah, it can be used. So done. Both.
And yeah,
So this is FRM. This is RPC.
yeah, this is the RPC that was talking about, and some of these best practices that you want to do. That data store transactions are expensive, and I mean, when you are using all these data store operations, you have to be very um, careful about how you want to use it. Like for instance, multiple reads, when you can actually get that information in your listener, then you shouldn't be reading, because from a performance perspective, it could be very costly. So there are, see, avoid unnecessary config operational reads and writes, as these are very expensive, because every time you will go into the data store and read it, especially if you have cluster and other things, it might even be residing in another node, so you might be actually going across and reading it, so it could be very expensive. So when you're writing applications, certain things that you may have to consider while doing it. Again, you can use the future callbacks to, and not wait on the thread to actually write onto the things. You can actually wait, do a future dot get and see if that thing was successful or not. And then applications doing a CDTCN, like I said, cluster wide data tree change listener. And then the other thing is, when you register for these listeners, you have to see where you want to register in the tree. If you register at a very high level, any change that happens in the children, you will get notified. Then you may have to process a lot of data to see where things have changed. So, or as against where exactly you, so you have to be very careful about where you want to register the listener to suit your application. Yeah. So the other thing here, what we did was, in the listener thread, we did all this processing of actually getting the data, reading the data, writing on, forming a flow, writing onto the inventory config. All that we did in the same thread. But the ideal thing will be, as soon as you get a listener, you queue it into some other thing, processing queue or something, and then you release that thread, and you spawn another thread to do your heavy processing, because these listeners are actually coming from the infrastructure. So you don't want to be holding on to that thread. Like somebody was mentioning here, you might be bottled. I mean, there is only so many threads that the infrastructure can actually, um, but depending upon your thread pool size. So if you kept holding on to the thread and did all the processing there, then it would again, you might actually lose some of those other, events that is happening. So the best way is to spawn a thread and do your whatever business logic in that. Again, if you go to Genius, we have some provisionings there. We have what is called data store job coordinator, where as soon as you get some event, you can queue that and then release this. And that there's another threads that will get spawned depending on when depending on the queue, how the size. So there are facilities available. You can look into Genius to see how you can do this. Then application that runs on cluster, better performance is CDTCL, because I think we mentioned this before. If you want load sharing, it's better that you do cluster wide listener, so that on all the nodes this um, this DTCL will get fired, as against when you do only on data tree change listener, it will always get fired only on the leader, just one node. So the load on that node becomes higher. So some of these that you want to do. So this is all we have. I mean, there are of course scope that you can actually do more with this, but I hope you got a general idea of what it is end to end, from the rest through the middle layers of MDSAL, and what happens down south in the plugin and onto the data path. So this is just a sample. So, right. Perform.
So they, so we told you about that DTC and all, right? So there you can register for just a leaf node or a full node or a middle node. So if it is a linear thing, you have to listen all the notification for any even single bit of change will count. But with the tree structure, if you only register for let's say leaf node, so if there is any change in the leaf node, then only I will get the notification. So this is the advantage.
Yes, it does have performance implications, because other databases like Cassandra and other things, yes, you have better performances, but there are also initiatives, projects that's running on OpenDaylight, where you can plug in your own database also. See, sometimes that's where, like I said, MDSAL does come with its own performance implications. So there are ways, like I said, not directly writing onto it using your direct RPC, you can move to a switch. So there are ways of doing it.
Sorry? So this MD SAN database, whatever we have, is hierarchical. So what is your question?